Now we will discuss the solution of third question. The third question is explain the process of training, test and validation sets in machine learning. What is cross validation and how it differs from the simple train validation test split? In machine learning, we divide data into multiple subsets, that is, train the model, tune its parameters, evaluate how well it generalizes to unseen data. This prevents overfitting, where a model memorizes the training data instead of learning general patterns. Training set. The training set is used to fit the model, that is, to learn the parameters or weights. The algorithm uses this data to find patterns between input features X and target labels Y. Example, for regression model, it learns coefficients. For neural networks, it adjusts weights. The goal is to minimize training loss or error. Validation set. The validation set is used to tune hyperparameters, setting not learned directly, such as learning rate, number of layers, regularization strength, etc. It helps decide which model configuration performs best without touching the test data. Goal is to choose the best model and prevent overfitting to training data. Cross validation, that is CV. Cross validation is a resampling technique that allows better use of limited data by repeatedly splitting it into training and validation sets. Most common type, k-fold cross validation. The data set is divided into k equal folds, that is subsets. The model trains on k1 folds and validates on the remaining fold. This process repeats k times, each time using a different fold as validation. The average validation performance across all folds gives a more robust estimate. How it differs from simple train validation test split. The first is data usage. Simple train validation test splits uses one-time fixed split, whereas cross-validation repeated training and validation on all folds. Efficiency. Simple train validation test split may waste data if data set is small. Cross-validation uses data more efficiently. Performance estimated. In simple training, validation test split may depend on which samples fall in validation test. Cross validation most stable averaged over multiple folds. When used, simple train validation test split are used in large data sets, that is, deep learning. Cross validation is used in small data sets, that is, traditional machine learning. Output of simple train validation test split is one train model, whereas cross validation's output is average performance. That is it for today. Thank you.